Have our Chapter 8 homework quizzes today. But before we do that, I'll take some questions. If anybody has questions from homeworks and stuff. Edie?
Can you go over 38?
38? Sure. Hi, Jack. All right. So it says, given the vertices below, find the side lengths and measures of the interior angles for the triangle below. So what I'm going to need to be using to do this is my equation for the angle between two vectors is what I'm going to use to do this. So if you didn't remember that formula, that's what we're looking at right there. So I'm going to start just by kind of sketching myself a little picture of what's going on, so I make sure that I'm like finding the angle that I'm actually think I'm finding. So I have -2, 1. -8, -4, I'm just going to guesstimate it. And then 5, 7. This is a pretty stupid looking triangle here. I don't know, looks something like this maybe. All right, so I'm going to go ahead and find, this was X, Y, and Z. So I'm going to find angle X first. So that's going to be, I'm going to need the vectors XZ and then XY. Everybody's okay with that? So I'm going to think about it like XZ and then XY. So I'm going to do my, first thing I'll do is my head to tail to get them into component form. So Z is the head because the head of the vector is above the Z. So I'm going to have 5 and then minus the tail, which is the X. And I do that for both the X and Y components. We'll do the same thing now for XY. Again, the Y is the head because it's over the head of the arrow. So far, so good. Okay, so now that I have that, I can say angle theta is cosine inverse of the dot product of U and, well, let's do these all separately. It'll be just easier. So I need the dot product of U and V. I need the magnitude of U. And then I need the magnitude of V. So let's just do all these separate. It'll probably just be easier. So the dot product of XZ and XY is going to be the product of the X components plus the product of the Y components. So that's -42 plus -30, so -72. Then I need the magnitude of XZ. So that's the square root of 7 squared plus 6 squared. So 49 plus 36 is 85. And again, I'm not going to worry about reducing anything here because none of this stuff is part of a final answer. It's just going to go into my calculator anyway. So I'm going to save myself the hassle. This is like the worst problem in the entire problem set, by the way. 36 plus 25 is 61. So that first my angle x then is going to be cosine inverse of the dot product over the magnitudes multiplied together. So I'll do that in my calculator. Before I start, I'll make sure I'm in degree mode because that seems the most reasonable. I'm going to use that fraction command to make a fraction on my calculator because I have a multiplication problem going on down there, although I guess I could just write it as square root 85 times 61, but so I get 179.2, which is kind of what it looked like in my picture. It looked like almost a straight line, so I'm pretty relieved at that. So far, so good. Colby? No, I have 2 more angles to find still. Although the first one is the worst one. So the next angle, let's find, say, let's have that be angle Z. So I need ZY and then ZX, right? ZY and then ZX. Now, ZX and XZ are basically the same vector, they just have opposite directions, right? So I don't even have to head to tail that. And I also don't need to do the magnitude because I already have that. So that's for free. Oos. All right, ZY. So Y is the head. So when I do this, I have -8 minus the tail, and then -4 minus the tail. So that's -13 comma -11. So the magnitude there of ZY is going to be -13 squared plus -11 squared. So 169 plus 121 is 290, I think. Yep, that sounds right. And then I'll do their dot product, ZX dot ZY, which is just going to be -13 times -7 plus -11 times -6. So 13 times, or -13 times -7 is 91 plus 66, so that's 157. So angle, what did I say with this? Z is what we're finding, is going to be cosine inverse of 157 over square root 85 times square root 290. So we do it again. Is this all so far okay, Edie?
Yeah.
Yeah, just a hassle of a problem.
Yeah.
Having to do all the angles. Should have just asked you to find the obtuse angle or something. So I get point, I guess we'll go 0.4 on that. And then the easiest one we'll have to do, angle Y will be 180 minus 179.2 minus 0.4. So 0.4 again. Is that?
Yeah.
Yeah, just kind of sucky. In that there's a lot to do if you have to do it for 3 angles. And you're given coordinates instead of components. It's just like extra steps. Colby, you had one?
No, I just have a question about.
Yeah, go.
When you're on like this one or like any of them, and you're heading in a direction, do you like use like how do you know if you're gonna use cosine, sine, or tangent?
Okay. So we didn't do any direction on this one, but if you want to talk about direction in general, here's what I would say. Anything in quadrant 1 is like 0 plus alpha. Anything in quadrant 2 is 180 minus alpha. Anything in quadrant 3 is 180 plus alpha. And anything in quadrant 4 is 180 minus alpha. And alpha is always going to be tan inverse absolute value y over x.
So you're always gonna do
Always use tangent. Because if you have component form vectors, you always have x and y. So just use tangent. If you do the magnitude, could you do sine or cosine? Sure, but like, why use a number that you had to calculate yourself versus the number that you were given in the problem that you're sure is you didn't make a mistake on? I would just use, you could use the other ones, but like, you never have to. You can always just use tangent. That's the one I would always use. Is that? And this picture, I guess I never wrote this down, but this is probably helpful, right? To tell you whether you should be, what you should be doing when you're finding that direction. That's a good picture. I just thought about that 2 seconds ago, but that's maybe something to put on a note card or your half sheet would be a decent idea, particularly if you're not confident about that aspect, which I think is sometimes the hardest part. Yeah, Tia.
Can we do a problem when we use that?
Sure. All right. God bless you. Sneezerific, huh? Yes, sir. Yeah, there's 2 right there. You're welcome to either one of them. Sure thing. All right. So, Tia, let's just do number 7. So the problem here says to find the magnitude and direction for the vectors. So I would start just by finding the magnitude to start. What's the formula for magnitude?
X squared plus y.
It's the square root of the x's squared plus the y's squared. So that 3 squared is 9, negative 4 squared is 16. 9 plus 16 is 25. The square root of 25 is just 5. And then to do the direction piece, I'm going to plot my vector. So it's 3 over and 4 down. So it'd be like down here. So I'm going to do that one because I'm in the 4th quadrant. And my alpha is always going to be tan inverse absolute value of my y coordinate over my x coordinate. And then it's just calculator time. Does that feel good? Okay. You might have to do those things on the quiz today. Calculate a magnitude and a direction. Just saying. Yeah. Kiara, did I see it?
So the first one is just magnitude.
Yes. Absolutely. Do you guys remember how to change a magnitude and direction into a component form? So like a problem like this. So to go from magnitude and direction to component form, it's just magnitude times cosine of direction, comma magnitude times sine of direction. Hopefully that's easy to remember because cosine is x and sine is y, just like it is on the unit circle. So in this problem, I'll do 4 times cosine of 218, and then 4 times sine 218. And then I just go to my calculator and type this stuff in. Right? Is that okay? Yeah? One person's answering. Thanks. So I have negative 315 comma negative 246. That's my magnitude and direction to component form. How about what if I give you a vector described as 2 points and ask you to give me the component form from it? Yeah, it's actually, we don't need magnitude at all, but it's just going to be that head minus tail thing. You're right there. So if I want vector AB, which is the head and which is the tail from A and B? B is the head, A is the tail. And I can tell just because of how the arrow is on top, right? So I do head minus tail for the x's, and then head minus tail for the y's, and I'm done. Yes, Mariana? Uh-huh.
When you're trying to find the and there's one of the questions, you like 180 plus the alpha or like 360 minus alpha, like how do you know if you 360?
So this picture right here. So it just depends on what quadrant your vector is in. So if you're in quadrant 1, you just do 0 plus alpha. Quadrant 2 is 180 minus alpha. Quadrant 3 is 180 plus alpha. And quadrant 4 is 360 minus alpha. So like on the previous problem, because my vector was in quadrant 4, I knew I should do 360 minus alpha. Does that feel good? Okay. And just as an FYI, I dropped this guy in the other day, which is just kind of showing you how to translate in between these different forms of vectors. You know, so if I have 2 points and I want to go to component form, I do the head minus tail. If I have component form and I want to go to magnitude and direction, to get the magnitude, I do this. To do the direction, I do that. You know, if I want to go from magnitude direction back to component form, I do this. Magnitude times cosine direction, magnitude, you know. So I kind of drew this up here for you guys to see how to translate back and forth between these forms. I figured that's probably helpful. Notice that component form is like the central hub. That's where you kind of pass through component form to go to anything else. So if I wanted to go from linear combination to magnitude and direction, I would do that. Go to component form first, which is really easy because it's just like take the A and the B and that's my component form. But does that feel okay, guys? Okay. So I put that in the OneNote also. I figured that's helpful. Somebody asked about it in 8th hour, 4th hour yesterday. So I was like, okay, well, let's draw out, maybe would a picture help? And they're like, yeah, let's do that. And I'm like, okay. So I made this and I was like, well, I should keep this and put it. So I like made a little bit neater version where I hand wrote it or whatever. Because this is hard to do electronically. And then dropped it in for you guys. So there you go. That's there too. Again, if that's something that you feel like would be useful to you, something you could go and put on your half sheet if you feel like that's a good way to consolidate all these formulas in one place without a bunch of words, you know, showing you where to use them and when to use them or with what stuff to use them. That's there for you guys. Yeah, you're welcome. Again, if you're, you know, if you have questions or if you have something like somebody's just like asking, like, I don't understand like, what are we doing? Like, why do we want to do these things? And I'm like, okay, well, this is really what's going on. And they're like, oh, yeah, that helped. So it's like, okay, well, let me just keep that then, and we'll save it for every year, and we'll do that again. All right. Does anybody have any questions before we start this homework quiz? All right, pencils and calculators. Here we go. Yeah, here. There's one left, so you're last lucky customer there. Just as a heads up, when you finish this homework quiz, you have a Delta Math assignment to start on, doing vector stuff. So here, we'll do this.
Should I,
We can do this later.
yeah, I don't really know anything about it. I have, can you give me like the homework that I missed out on? So I can work on it with my tutor? Sure. And then I'll take the test later.
Yeah.
So wasn't your last time you can take it tomorrow or Wednesday?
Yeah, tomorrow will be okay. I mean, you've done all this stuff.
Thank you.
You know, it's all 8-1 stuff, but it's fine. If you want to do it, you're welcome. If you just want to wait, it's fine too. But it's all just 8-1. So it's up to you. Yeah, that's fine. No big deal. I'm not in a rush. Oh. All right. So here, I'll just shoot you an email with the homeworks that we've done so far. Does that sound good? Kiara? Okay.
anxious to like, should we round these? Like, can we? Do we leave them at the second?
Yeah, rounded to, 2 decimal places is fine.
Okay.
Sounds great. Hey, Ethan.
Radians or
Degrees the whole way through. Yes. I'll start my folder. Yes, go ahead.
Should I do 2 display office for this one?
Yeah, 1 is fine. It's not that big of a deal. It's one of those where it's like specific enough that whether you round it 1 or 2, I know that you did it. You're welcome. I got this all.
That's good.
When we do this stay at 4 months, this just changes to 3, right? Because it's
Yeah, the absolute value. Yep.
Sorry. There you go, bro. So for this one, I just simplify it, right? I just plug that in my
Yeah.
calculator.
Yeah, as long as you're in degree mode, it
for
should be
this
good to
one?
go.
Just plug it in like this, and then that's the answer.
Well, you have, like if you draw this picture, you're here, right? So what you're looking for is this angle.
Okay.
What you found is that guy. Right here. So you just need to figure out what this is.
Okay, sounds good.
Okay?
Thank you.
Yeah, no problem.
Yeah, I think the rest is fine. Just that's all.
Okay. Oh my goodness. Thought they're coming through the wall. Right in here, Vincent. Thank you, my good man. Thank you. Again, as some of you guys are finishing up, there's a Delta Math assignment to start on. It's kind of a big one. But most of the stuff is pretty straightforward, just like operations and on vectors and stuff. And there's chargers on the power strip. If you want to plug it in, you can get a charge and pick it up, at the end of CT or whatever. I don't want you to be without, you know what I mean? How to go, Colbs?